So this is a live coding hangout for Python coding in combination with the BitShares decentralized exchange. And this time we're focusing a little on something that I have called initially exchange bots. It's not really a bot, it's more like an infrastructure for coding bots. And it's in the Python Graphene Libs repository on my GitHub account. MIT license, so you can do with it whatever you want. And the idea here is to have some code that makes it easier for people to write coding bots for the BitShares decentralized exchange. So all of the blockchain related stuff and things are abstracted away from the user. All the user needs to do is run a CLI wallet. At the current stage, run a CLI wallet for signing of transactions. And the CLI wallet, I think it's written somewhere on here. No, it's not. The CLI wallet, actually, you can run the CLI wallet when you have compiled BitShares. It's in programs, CLI wallet, and all you need to do is to open up a RPC HTTP endpoint. To something localhost style thing, and a port. I usually take 1892 for CLI wallets, as we can see later in the config. And once this you have opened the CLI wallet, just unlock your wallet, provide the passphrase you have used, so that the wallet can actually sign any transaction for you with the private keys that you have in the CLI wallet. Okay, so the idea now is that you essentially have just a single configuration file. That's that one here. And you have a bot infrastructure that does whatever you state in the config. You have a main file that runs the configuration or executes your bot just a single time. The code is actually pretty simple. It's initializing the bot and does whatever you say the bot should do when it initializes. There's also a run continuous mode. It's a little more code. It's bot run. That is something that runs asynchronously and, for instance, can execute any or call any ticks for incoming blocks or filled orders or something. The bot itself is a little more sophisticated code. Let's start below here. There are some calls, for instance, the run and execute and cancel stuff. Oh yeah, let's take a look at, here's a script that cancels all of your orders. Literally very easy. And the bot itself has this init function, and then what it does is it loads a protocol. We're going to look into this in a second. It loads a protocol over here. You can define the specific tasks of that protocol in the configuration file, and you can load many different bots, and it's executing them one after the other. And one of these bots actually are in the strategies folder. So, for instance, there's a strategy that is called, what's the easiest one? A strategy that is called maker sell buy walls, and that thing does nothing more than put a sell and a buy order at a given spread. We can take into this in just a second. And the configuration of this bot is quite easy. It works like this. This is the configuration file. This is basically everything you need to do if you want to just run a bot, an existing strategy. You have the configuration stuff for the wallet. And the witness URL is just the full node. It's currently set to be the testnet. We have markets that we are interested in dealing with. In this case, this is just a market of an asset temp A and an asset live. I created on the testnet just for this purpose here. A market separator, this is just like how you distinguish different assets in these market pairs. Then you have a main account on the network that you're interested in. the bots currently just work on one account. So if you want to deal with multiple accounts, you just run different bots in parallel. So different configuration files. There's also a safe mode. It will just tell you what it will do, but will not actually execute it on the blockchain. So there's no buying or selling or anything. It will just tell you what it's going to do. And these lines here are basically the core or the basic configuration stuff you always need for this trading or bot infrastructure. Now there comes interesting stuff that is loading actual strategies. And from this here, you can see that it loads from the strategies maker file the classes maker ramp and maker sell buy wall. This is the one we are currently interested in. And now let's say we define some bots in a dictionary. And the first and currently only bot we are using is the maker wall. And the maker wall can be defined as, okay, which bot strategy is actually executed. This is the maker wall class as it is loaded from the other file. And then there are a bunch of parameters. And the parameters are mostly just like handed over to the strategy itself. So in this case, we have markets that we are dealing with. We have a target price of, say, 10 live per temp A. We have a target price offset percentage. This is just like if you have here something that instead of concrete price, you could also take the feed. And some bit assets, for instance, have a premium. And if you want to sell above the premium at a given spread, you can put an offset over here for like 5% or something. Here we have our fixed price of 10.0. We have a spread over here. It will put an order on spread half on the bid and on the ask side, plus minus around the target price. There's also something about the volume that we want to sell. It's like 10% of the assets available in my account for these two assets. And we can do symmetric sides so that in the end we don't put all, like if your balances are not symmetric, then if you have this on false, then your orders will not be symmetric. And then, yeah, you can also just serve one of the both sides and only buy or only sell. So let's take a look at this market sell buy wall strategy. It's actually not too difficult. So that's just some comments again, same stuff, same variables. And then there's this, this is the Python internal initial function that is called whenever you make an instance of this maker sell buy wall, which is, by the way, an extension of the base strategy. But let's take a look over here at first. So we have this init thing, and it basically just takes the settings. The settings are these variables defined over here, and checks them whether they are fine and set some default parameters and stuff like that. And then what init already does is it places orders. This line is essentially done for if you just want to call the bot once to just put orders and we are done. Then there's something that's called orders or order filled. This one would be called if you if the bot infrastructure figures out that there has an order being filled for this specific bot. And in this case, there's just nothing happening. The more interesting...
The order is cancelled.
Pardon?
Order failed is also called when the order is cancelled or expired.
When it is expired, that might be, but that shouldn't be. We can take a look later when we are going to take a look into the base strategy, but it shouldn't be the case. There's another thing that is called, I don't have it over here. This should really be just called if an order is fully filled, not even partially filled. This thing is called then fully filled. Cancelled, I'm not sure. we can take a look in a minute. Anyway, the place order is what makes this bot like do what it should, and well, it's like grown code. It could be way simpler, but because of these parameters we can define it, it kind of grew a little into more lines of code. For instance, there's this only sell, only buy stuff. Then there's this stuff that figures out the amounts that we want to spend on both assets depending on the balance and whether we want to have symmetric is not even here. I think symmetric is below somewhere. So this is like what assets are involved. This is the amounts that are involved from both assets in our bot. The ticker is something we are going to take data from the DEX. The ticker here gives us all tickers from all the markets that we have here in watched markets. So we can take a look over here for M in markets. Okay, this is for M in self-settings market. So this is self-settings markets, and this is watch markets. It's a difference because one configuration file could deal with multiple markets. However, the bots themselves could deal with different sets of markets. So usually I have all of the markets my bot is interested in, or all of my bots are interested in, I put into watch markets, and then I can have plenty of different bots with different markets to serve with these parameters, and these are then stored in self-settings markets. So this is self-settings is whatever you hand over here in this dictionary, and the return ticker gives actually everything that is from the markets that is given by the watch markets. It's a little inconsistent, but it makes it easier for like combining different bots together into just a single bigger bot. Yeah. Anyway, there's just some stuff about target price with this offset and settlement price you can take from settlement or feed or whatever. Well, and then there's here these buy side or buy price and sell price, and then over here there comes the symmetric side. And this is actually the sell and the buy orders, these here, depending on the parameters here of the symmetric sides, and these actually execute the sell and the buys or placing the actual orders. This is self.sell. We haven't defined any self.sell, so obviously the self.sell and the self.buy are part of the base strategy. This is like yet another abstraction layer that makes it easier for people to actually use the infrastructure because they don't want to actually contact the CLI wallet and do all of that stuff. So there's this base strategy over here. And the purpose is to make things easier for writing code without thinking about too much what happens behind just, I want to sell something. And for instance, let's take a look at the sell order versus sell order. Here, sell. Thing is, we sell at a given market. So for instance, in the market is over here, in this market here, temp A live, this is the market. We sell in that market, so this is here. At a given price, the price is a float defined as in live per temp A. And the amount of quote we actually want to buy, that would be temp A. Well, it looks a little awkward, but this is how Poloniex is actually doing it from the syntax style of things. And then, well, there's just some reporting that we are actually putting something into the DEX. And the DEX is really like yet another abstraction layer that contacts the CLI wallet, builds the transaction, signs the transaction, broadcasts the transaction for putting a particular order. And the same thing actually we have for buy. And there are some other things that are used internally. For instance, there is in the init folder, we define a file name. These files are used to store states of your bot. And this happens over here, store. So for our bot, we actually get the state of our bot, which is like, which orders have I opened, which ones have I closed, which ones have been filled by the decentralized exchange, and I dump all of this into a JSON file, in a JSON formatted file over here, which also contains the ID of the orders, and I can restore all of this state from disk. Loading markets is like, this really figures out what has happened if an order is in the state but is not anymore on the blockchain. And it tells me here that reach market, not all orders. Well, yes, I think it really calls order filled also when it is cancelled. That shouldn't be the case. I think I need to fix this. Anyway, yeah, there are also some other methods that make life easier. For instance, cancel all, cancel mine, cancel this markets, and stuff like this here. These are basically just for distinguishing which actually cancels all the orders in all of the markets that my bot deals with. Cancel mine is just like this particular bot here. I could have like another one. This one is called Make a Wall. Here's another one that I call Maker RXP. This is another one, and I can cancel just the orders of this bot, but not the orders of that bot. And I can cancel also all the orders of a particular market. Well, yes, this is the difference here. And I think that's basically everything about this infrastructure. Now there comes the methods that we are overloading in our particular strategy. First of all, there's this init method. Let's take a look. We had it. Strategy. We have this overload over here. It deals with some default parameters and puts the actual place call over here. There's a method that is called tick that will be executed when you run the code continuously on every new block. In the maker kind of bot, there's no tick overloaded, so there's just nothing going to happen if you run this continuously. So that strategy works best if you just run it in a cron job or something. Unless you extend it, then you can, like, whenever there's a tick, load the market, see what happens, compare prices, see the history, and then decide whether to cancel my orders and replace them or whatever. So this is just like whatever happens on a new block, which is not yet part of this particular strategy. We can see we can take a look and another look on another strategy that does something completely different that uses the tick. Order filled, yes. Order matched. I had this originally, but there are some internal. I'm having some trouble with distinguishing whether a order is partially filled or fully filled. This is going to be available eventually, but not yet. And then there's also something that can be used for post-processing that is called order placed. This is like, it happens when, so the bot infrastructure works like this. Whenever you execute a bot strategy, you first load the state of the bot strategy from the previous run into your current state. Then you execute the bot. It does something, cancel orders, make new orders, something. After that bot has been run, it compares again the order books of your bot with what the state has been before it actually launched. And then you can compare. Has an order vanished? Then it's been either filled or cancelled or anything. Or is there a new order? Then you have a new order placed. And this is how you distinguish what actually happens when you run a bot. So for instance, if you have a order placed originally, and when you load the orders again before running the bot again the second time, and an order has disappeared, then that one has been filled from the decentralized exchange. On the other hand, if an order has vanished between start of a bot and end of a bot, then the order has obviously been cancelled. And well, this is the whole idea of why there is an abstraction layer behind all of this, so that we can deal with stuff like that easier. Okay. Anyway, this is the base strategy. When I coded this, I actually started with placing these buy and sell walls. There's a more sophisticated strategy over here that does not only place sell orders and not like just a wall. It builds up a ramp. It's a set of orders at a given percentage steps. Like they're like every 0.3% there's a new sell order. And in total, I sell 30% of all my stake, something like that. It's a little more involved, has some little ugly math in it, but well, shouldn't be too difficult for someone who's familiar with how to deal with bots. Anyway, we can do other kinds of bots here as well. For instance, there is one bot that is tracking the core exchange rate. And tracking the core exchange rate, configuring such a bot looks like this. You have this strategy that you can load with Python with from import this name here. Then you have a particular market that you're interested in, and you need to call this a market because of how the internal thing works. Core exchange rates are always denoted in BTS. So this is the quote, and we are now interested in the core exchange rate of MKR in that case. And this is kind of all the kind of parameters that you can define. For instance, the target, what the core exchange rate should actually be. For instance, I could say it should be the highest bid plus 2%. That's what's stated over here. You can have some other parameters as well. For instance, instead of highest bid, you can have last order, price 24 hour, or mid price between sell highest bid and lowest ask or something. There's a upper bound threshold that says 15% above that, and we should update the core exchange rate, or lower bound if the actual core exchange rate is like 4% of what it should be. Then it should be updated again. Or is it 4%? I think it's the premium is 4% what it should be. Well, and then there's this force flag that enforces that the core exchange rate is always higher than the highest bid, always lower than the highest bid. It depends how you define core exchange rate. But essentially, if you have this flag on false and you run into this case here, then people are going to exploit your core exchange rate, because the core exchange rate is then like an implicit market maker at the price that you define here, and people are going to exploit this pretty quickly. Skip blocks is something that happens if you run this code continuously. You have here a tick, and we don't actually want to check the core exchange rate just every block. This is why we can have here a skip block, and it blocks like 20 times 5 blocks and then checks again. Yeah, the init stuff is just like figuring out if everything's set up correctly, like the base asset needs to be BTS or something. Then there is something that is actually doing the update of the asset, like constructing the options, like for executing a call in the CLI wallet. Then there's like lots of calculations where it should be actually, depending on the parameters you have. And then there's this tick function. Tick function is, as I told you, It's going to be called every block. Well, and it takes again the return ticker function, figures out what the markets currently is, some parameters depending on the settings, and then it says here if the premium is lower than the lower bound or the premium is higher than the upper bound, then it actually is going to force an update of the core exchange rate. So another example, something useful for probably many, is this strategy here. It says maintain collateral ratio, and the idea is that you have a bot that has markets that are like market of a bid asset against its short backing asset. So the USD is backed by BTS, so you're in the market USD against BTS. Now, if you do something wrong over here, the script will tell you. It's like it tests over here that the short backing asset is really what you defined, otherwise it will just throw an exception. So there's nothing bad going to happen if you do something wrong over here. Then there's a target ratio, which is in this case 2.75, a lower threshold that says 2.5 and an upper threshold of 3.0. And what it does is it actually does that every block, as you can see. It checks whether the collateral ratio of your USD debt position, silver debt position, and gold debt or call position is in between 3.0 and 2.5. And if it crosses those two thresholds, then it will be updated to be 2.75. So if the price goes in your favor, then the collateral ratio will not be higher than 3 because you may want to have the liquidity. And it pretty much works the same way as the core exchange rate updater. You have the tick over here. You have some counter over here, not so important. You have here where is it? Here, list debt positions of your account, of the watched accounts actually, of the watch account. So this is the watch account or market account, and for every asset you have in the market list above here, it figures out whether the debt ratio of that particular position is in between the lower and the upper threshold, and if not, it will just adjust the collateral. Well, and adjusting collateral is something that is dealt with behind the scenes in, where is it? No, it's in it. Adjust collateral debt here. This is something that is self-DEX is. We can take a look at what self-DEX actually is. No, it's not over here. In the bot here. And you can see that DEX, with this DEX, it will be like handed over to the base class as DEX is DEX. And given to the base strategy. It looks a little ugly, but here it is. Self.dex is actually an instance of Graphene Exchange. And the Graphene Exchange, we had a separate live coding session for the Graphene Exchange. It's a whole bunch of other calls that make dealing with the decentralized exchange easier. It's actually made such that it is very similar to how Poloniex works. So there's a return currencies, return fees, return ticker with the stuff. There's also a return 24-hour volume, return order books, return balances, blah, 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 blah. There's also a sell and a buy order, buy, sell call, list debt positions. That is, of course, not available on Poloniex. Close debt positions, just debt, like the collateral here. Here's the just collateral ratio. You can borrow new stuff, and all of these calls are available in self.dex in your bot strategy. So self.settings are the settings that you get from defining the config file. Self.dex is the decentralized exchange, and then there's also self.dex.rpc. We had this over here. self.dex.rpc. That is then actually the connection to the CLI wallet. Depending on how nasty stuff your bot is going to do, you probably won't need that. Then there's another quite easy thing that's a refund fee pool. All it does is it takes a look at the fee pool of particular markets. Fee pools are all base with BTS in the base asset because the fees are in base. Then there is a target fill rate, a lower threshold threshold, and if the fee pool goes below the lower threshold, it will be topped up to the target fill rate. So it will always be 5,000 or less. And well, that code is not too complicated. For each market, self-settings markets, it gets the quote symbol, the asset, the core asset. Why do I get the core asset? Because of the precisions. And I have the fee pool over here, which is from the dynamic asset data ID from whatever quote asset you actually want to take a look. And well, if the fee pool is below lower threshold, then fill fee pool. And fill fee pool is there's a call in the CLI wallet that states self-dex RPC fund asset fee pool. It's like pretty easy. So this, I think this is the easiest strategy you can actually build that has some value. Then there's another thing, but I'm not sure that this is actually but not yet done. Work in progress. Of course, there are people coming in that want to build their own strategies. Some of them will be open source or public, and probably most of them won't be publicly available. Well, this would be it. Are there questions from the audience?
Not really. At least this seems pretty clear. I looked into the cancelled orders thing.
Yeah, I think I saw what I did wrong already.
Yeah, you didn't remove the order from the state when you cancelled an order. I think.
Yeah, there are two different ways of doing it. Removing it from the state when you cancel it, or alternatively, when you load it over here. Yeah, when you store the new state here, when you store the new state.
You store the things on the DEX?
When you store the state, you figure out which of those have been actually canceled. Then you do the calling of canceled orders here and remove them from the state in before you write them onto the file.
Oh yeah, that's
this you can do as well. Yeah.
I wanted to make. I almost made an issue about it. Do you want me to submit it or?
Yeah, submit it, and if you have some time left, maybe even try to solve the issue.
Well, if I would implement the issue, I would probably do it by removing the order from the state when you cancel the order.
Yeah. Just note that there's more than just one cancel thing. There's like 4 or so.
Two, and there. Oh, I thought there were two or three.
3 is it? Yeah. It's 3. Yeah. Okay. That would be nice.
I will fix it then.
Cool. Thanks a lot.
No problem.
Yeah, and if you find any cool ideas of what kind of strategies might be useful besides those that you can use for trading, then just drop me a line. Like you could literally like monitor any account activity in this infrastructure as well. It's not necessarily something with a decentralized exchange.
Yeah, I'm hoping to do some freelance work in the next months.
Mm-hmm.
If I haven't got anything, I'll probably try to contribute something to the graphene lib, and maybe if I got an idea for a bot, I'll probably make it and make a pull request for you.
Cool. That would be nice. Awesome.
Yep.
Was a pleasure talking to you.
Yeah. Thanks for the well, the explanation. Didn't really need it, but I wanted to see how you'd explain it and what tools you use mostly.
Well, there's a YouTube video now, and some more people can take a look at the code and maybe make use of it.
Cool.
Yeah. Awesome.